about us, my name is Najam Siddiqui, and a colleague here, Moin Musammil. We work for in Gemalto in the Enterprise and Cybersecurity Department. Well, you may not have heard of Gemalto, but it's not a household name because the products we have is mostly, business focused and not consumer focused. But Gemalto has been, developing secure digital solutions for a while for enterprise, for government, for banks, and telecom operators, etc. We are currently involved. The projects that we are involved in is we have Gemalto's Safeness Trusted Access, which is an identity and access management solution with a wide variety of strong authentication methods, and also we are involved in Gemalto's data protection on demand, which is a data protection solution on the cloud. So we've been working on cloud or developing cloud solution for a while. So we've encountered many challenges, specifically pertaining to configuration in the cloud. So today we are going to use that experience and lessons, and also done some some study. So we're going to share that with you. That hopefully will help you in solving your problems pertaining to configurations. So quickly on the agenda, so we'll go over the overview of secrets in the cloud and the types of configuration secrets and traditional ways for configuring secrets and what is desired of a secret management solution. We'll go over some of the available solutions that we studied, and finally the conclusions. So first, why is it important why is protecting configuration secrets important, right? So we hear about breaches all the time. So as enterprises, we understand there's a strong focus on protecting business sensitive data, right? So we have, we make an effort to encrypt SSN, credit card numbers, or any other data which is business sensitive. Most of the time, the security of configuration secrets is usually assumed, right? For historical reasons, because they are in a in a data somewhere, a data center somewhere, where it's on a very trusted environment. Even though typically configurations are clear in the config file, sometimes due to the limitations of the tools that we are using, it forces us to have that configuration secret in clear. At times it's getting logged in a log file somewhere, but still the security is assumed for configuration secret. However, we need to keep in mind that if we get hold of configuration secret, it's very easy to then work towards getting the business secret. As an example, let's say we have an application that is protecting credit card numbers, right? So it's Java-based example. So we are encrypting the credit card numbers in the database, right? Well, we don't have that much money to spend on an HSM, so we use an SSM. We have a Java key store. Well, it's protected by a password, right? But we put the key store in the configuration. We put the password in clear somewhere config file, and also the database credentials on somewhere on the same system. So if as an attacker I get access to the database credentials and the key store password in the key store, I have all the information that I need to connect to the database and get to the business sensitive secrets out. So that's why it's very important to have a focus on protecting the business, protecting the configuration secrets. So that is one part of it. The other is expectations from a cloud application, right? So the expectations from application have changed quite a bit, right? Today, with cloud application, the expectations are they're highly scalable, highly available, ephemeral nature, in the sense that you have an application, throw that away. You can create tens of applications, horizontal scaling. There is no no configuration which is inside the application itself, right? And then we have the concept of dynamic configuration that is coming in, that is configuration, like getting services on demand. Like you get a data store on demand, so your credentials for those data stores are configured on demand. So we have dynamic configuration, and then we have the externalized, and because of this we have the externalized configuration pattern, where because of the expectation of a cloud application, you want to externalize your configuration secrets.
Okay. Now that we understand the business need as well as the technical expectations for configuring secrets, let's have a quick overview of the configuration secret management. So let's start with the different type of configuration secrets that you'll typically have in your configuration files. So one of the very common one you'll have configuration is the service credentials. These credentials could belong to your data services, which could be your databases, your caching services, or some analytics system like Elasticsearch or Splunk. Those credentials could even belong to some internal components or services, or they could belong to some external services like your SMSCs, your billing system, or your cloud services. You can also have some private keys or secret keys in your configuration. One of the typical one is the TLS server keys, which are used to basically expose your application on the HTTPS. Depending on if you are using the client mutual auth, you could also have the TLS keys for the clients over there also. You could also be using the SSH keys or VPN keys to the other data centers, or you could be using some encryption keys to encrypt some of the pieces in your, some of the sensitive information in your application. Or you could be using some key stores to basically store any of the keys mentioned above. Another common type of configuration that you typically see nowadays, especially with the popularity of Connect or the different API mechanisms, is the API tokens or the keys. So that's another, that's related to the service credentials, but since it's getting a lot popular nowadays, so we end up putting that as a separate item. Okay, so now let's also talk about what are the traditional ways of managing those configurations and what are the typical issues with those. Like as a developer, you could embed those secrets in your code, okay? So easy implementation. But the problem with that is if you embed your secrets in the code, now those secrets would be part of each and every clone or fork any developer does. Or even if you delete those secrets, unless you explicitly purge those files from your repository, they are going to stick into the history of the code repository. The problem with that approach is that it makes the access management for those secrets very difficult. Mainly because the code needs to be accessible by a lot of developers, but the secrets should generally be accessible by the operations team. So you should generally avoid that approach. In case you're wondering if one of your developers has already checked in, what you can do, there are a bunch of tools available which you can use. They normally use some regex to go through the whole repository and figure out if there is already some secrets there or not. I listed a couple of them, but again, they are just as an example. Okay, if you cannot embed the secrets in the code, maybe we can embed them in the binaries, okay? But the problem with that approach is if, depending on how easily that binary is available to the user, somebody can basically reverse engineer that and can extract the secret out of that. Let's take an example of a mobile application. The mobile applications are easily accessible to you guys on the App Store. Imagine a scenario where the secret is embedded as part of that mobile application. Now, as an attacker, I can basically download the mobile application and then reverse engineer over there and figure out the secret out of that. The similar thing is you can provide the secrets as part of the build time variables. Again, at the end of the day, that secret would become part of the binary, and the issues which I mentioned above are applicable over there also. Okay, so since we are not going to use these secrets in the code, or we don't want to embed them in the binary, what about providing them through the environment variables? Okay, an approach people have been using for a while, but especially with the container-based, now the Docker containers, there are a lot of issues with that approach. One of the common one is if you do Docker inspect on a running container, it will show you all the environment variables over there, which means anybody who has access to the machine should be able to view the secrets values over there. Or if you're using Kubernetes or OpenShift, okay, then you don't even need to have access to the machine. As long as you have access to the dashboard, those values will be by default visible in plain text to you. So don't use those environment variables to provide the secrets over there. Another drawback with this approach is that all values provided through environment variables are actually accessible by all the processes running in the Docker container. Again, so quite a few issues with that approach. So another typical way, and actually this approach is very common nowadays even, that the people provide those secrets in plain text in configuration files or store them in the database over there. Again, even though people know the issues with those configuration secrets, but typically that's the approach they use because of the limitation with the tools, like the example which Najam gave about the Java key store, the passphrase needs to be provided in the server file. Again, the problem with that approach is anybody once you get access to that persistent storage, whether it's a file system or database, the secrets are there in plain text, so you can extract out from there. So now we talked about the different issues with the current approaches that we are using. So let's look into what are the features we want in our secret management solution. So obviously we want something which has the secure secret storage, which basically should let you store the secrets it should be well protected enough over there at rest as well as during the transport. It should also let you define who is able to access which secret, probably even at what time. You should also be able to configure your applications to use those secrets easily and should be able to integrate with those easily over there. And it should also provide you probably the usage audit. Basically, you should be able to figure out who used this secret from where at what time. And you should also have a mechanism to take backup so that you should be able to recover from a disaster situation, like the service is down, you should be able to get back to that quickly. Depending on what are the security requirements you are following, you may also be looking for some solution which provides you some secret management, renewal management, like the PKI card I'm using. For that the certificate expires every year, so it needs to be renewed at that time. And last but not the least, you should also have a mechanism to be able to revoke certain secrets and should be able to delete those also.
Okay, now we're going to cover some of the popular deployment mechanisms that are in use and how we could protect configuration secrets in those, using those solutions. The first one we're going to look at is Kubernetes secrets, a centralized mechanism to configure and provide secrets to your application, to containers, right? I mean, this is a very simplified diagram, but I mean, the idea is, as an admin, the first step is the admin would somehow, configure the master keys, right? So this is at the time of deploying, or it's a Kubernetes encryption config. There's a config file in specify what keys to use. And then once you have your cluster running, and the process is to create those secrets. The secrets are stored in etcd, encrypted if it's configured properly. And then when you deploy your applications, then Kubernetes makes these secrets available to the application, typically on a tempfs mount, which is an in-memory file system. So in terms of the features, it's a central system that centralized secret management solution. It supports encryption for text and files. The secrets are protected at rest and in transport, but you have to configure it correctly. And then we configured the point earlier is for containers, secrets are not persisted on the disk when they are provided. The secrets are provided to your containers. They are not persisted on disk, but provided in an in-memory tempfs file system. Kubernetes provides audit capabilities using Kubernetes auditing. One thing to keep in mind is by default there's no encryption, and the word secrets has been around, from the beginning. Or before encryption, and over there, before it was just base64 encoded, there was no encryption. So we need to be aware that you have to use version 1.7 or later. In terms, again, by default, there's no encryption, so you need to be aware of that. It's only base64 encoding, and Kubernetes provides some cipher mechanisms. A secret box, it's fast, so it's speed-wise, it's good, but it's a new standard, may not be acceptable in some environments, especially if you have compliance requirements. It's basically a stream cipher. And then you have AES-CBC, it's the recommended one, and slightly slower than secret box, but it's a well-established cipher. You have AES-GCM, it's faster than CBC because you can do crypto operation in parallel, but requires key rotation. So unless you have an automated mechanism of doing key rotation, it's not recommended. And then finally, you have the capability of integrating with an external KMS, which we'll cover. So Kubernetes has provided a way that you could integrate with an external KMS or external HSM. And HSM over here, the hardware security module. So the way it works is that Kubernetes encrypts the data with the data encryption key. The data encryption key is encrypted with a key encryption key, which is in the KMS, and Kubernetes will store the encrypted data and the encrypted data encryption key in etcd. Also, it rotates the key every time. There's key rotation of the key data encryption key is rotated often. However, we need to keep in mind that it requires custom plugin development. So the way I understand it is the Kubernetes obviously is not going to integrate with all the KMSs, SSMs that are out there, right? So it basically calls a local service. So you have to run a local service on the master node that Kubernetes would invoke for KMS operations. So Gemalto provides an HSM on demand as a KMS provider, which could be used as an external HSM. So in terms of the recommendations, don't use the default no encryption, right? Don't get fooled by secrets, just the word secrets, right? Use external KMS, because if we use the other providers, the master key is still in clear on the master node, right? So it's again the problem. Yes, if you could get hold of that key, then all your secrets are. You could get access to all the other secrets. Run etcd with TLS, otherwise you don't have protection in transport.
Okay, next we are going to talk about the HashiCorp Vault. That is basically a centralized secret management solution provided by HashiCorp. One good thing about this solution is that is platform agnostic, so you can use that with any of your current existing infrastructure. At very high level, if I give you the overview of the architecture, is in this, as administrator, I would go and set up the secrets in the vault, and the vault would store those in the encrypted storage over there. After that, I can configure my application to be able to request for those secrets. Vault would verify that the application has access to those, and then it should be able to return those secrets back to the application over there. So in terms of features, it provides a secure secret storage. The secrets are protected at rest as well as during the transport. The infrastructure admins, which let's say the OpenShift or Kubernetes administrators, they should not be able to see the values of those secrets at all. Only the vault admins can. So there's a difference now between the infrastructure admins versus the vault admins. Now, to ensure that only a single administrator, vault admin, cannot decrypt all the secrets and view those, you should probably use the split master keys over there to avoid that happening. Vault also lets you manage the static as well as the dynamic secrets. By dynamic secrets, it's meant that the Vault would create those secrets when application would require those. For example, your database credentials, when an application would require for those, at that time it would go and create those credentials in your database server, and then would return it back to the application. You can also use Vault as a data encryption as a service. Mainly what it means that Vault won't store any encrypted content over there, but you can use that to encrypt or decrypt content for you, and then you can store that in your existing application the way you were using earlier. You can also limit how long the credentials would be valid in the vault. You can basically limit that by using the leasing concept of that. And after that predefined period, the secrets would be revoked automatically. Vault also lets you revoke the secrets individually, or you can also revoke them by a tree. Like you can specify, okay, revoke those secrets for any secret accessed by this user, or you can specify revoke all the secrets of this particular type. Vault also provides a very detailed audit log in terms of any authentication happened to it, or any token creation, or any secret related activity like access to that, or a creation, or revocation, etc. So it provides detailed audit log for that. I want to give you a quick overview. If you want to use Vault, what kind of steps are involved over there to set up that. Obviously, you would first start the Vault server. When you start that for the very first time, there is a initialization process would kick in. As part of that, you would be asked to set up the master keys over there, as well as it will give you a root token account, root token. That root token is very important because you will be using that token to configure the vault in the next steps. Also, another thing is whenever you start the vault, it will always be in sealed mode, and you would need to explicitly unseal that. By unsealing, we mean that you would need to provide the master keys so that the vault can decrypt the content over there. Basically, the vault will not store the master keys locally at all. So as a vault admin, you would need to provide those keys on the server startup. Once that is done, as a root operator or administrator, I should be able to configure the authentication method, which my applications would be using to authenticate to the vault. And then I would also configure the access policies, and I would also configure the secrets over there, which my applications can request later on. So once that is done, now I can configure my applications. The application would be able to authenticate to the vault using the authentication method I configured earlier, and then application would be able to request those secrets which it has access to. Now, I want to give you a quick overview of the authentication methods supported by Vault. Again, it supports big variety of those, and I haven't even listed all of them over here. Okay, so but one important takeaway from this slide is some of those authentication methods are strong enough, like we studied Kubernetes over there. But some of them probably not as strong as this one, like the traditional username, password, and LDAP. Considering you are putting all your secret configuration over there in the vault, so it would be probably much more important to use a stronger authentication method over here as opposed to the traditional username, password, or LDAP. So in our study, as I said, we considered the Kubernetes authentication method. So I want to quickly give you an overview. How does it work? So basically, when you deploy Kubernetes, an application of the Kubernetes, you can tell it in the configurations that it should mount a service account jot at a particular location of the pod or container, and the container should be able to use that jot to talk to the vault for the authentication. Once the vault gets that jot, since it does not trust that, so it needs to call the OpenShift or Kubernetes Master API to validate that. Once that is done, it should return the token. It should generate a vault token and send it back to the container as part of the step 3. And after that, using that vault token, the application should be able to request the secrets and get all the secrets which it has access to. In terms of recommendations on if you want to use HashiCorp Vault, make sure you protect your master keys well enough. If you lose them, okay, there is no recovery mechanism available. If you lose them, all your encrypted secrets would be gone. Okay, you should protect your root account token because that's a full access token. You can use that token to change the existing configuration of the vault. So make sure it's well protected. Again, you should be using sharded master keys or split master keys to avoid the scenario where a single person can decrypt the vault and view all the secrets over there. Again, this would make the vault startup a bit complicated because now you need to have multiple people available at the same time to be able to start the server over there. So yeah, it makes the vault startup a bit complicated, but probably the kind of stuff it has, it's probably not that big of a cost. Again, as I said earlier, use a stronger authentication method. And one thing is make sure you don't try to automate the unsealing of the vault. That is a manual step by design. But we understand that this makes it a difficult in terms of automation environment, where if the service goes down, there's no mechanism to automatically start that. So that makes it difficult, and that's a challenge. I'm not sure how to address that right now, but that is something to think about for sure.
So let's look at Azure Key Vault. So if you are on Azure platform, this is a good one to. It's a very good solution for protecting any kind of secrets. Right? So it's a secure management service from Microsoft for the Azure cloud platform. Again, I mean, a very simple diagram over here. You have your admin that would create the Vault service. And then you have your developer and your applications, and using that Vault key service to create keys, do crypto operations, and so on. So in terms of the features, it stores secrets, keys, and certificates. One of the big key point over here is it's HSM backed secret storage. And one thing that stands out for Azure Key Vault is it provides certificate lifecycle management. It's not only a storage for certificates and keys, but it provides so you could use it as a CA as well, and then manage your certificates for your backend services. I think it also you could get public certificates also. Not so certain about that one. One big point over here is integrated access control with Azure Active Directory. So if you are on Azure, then you get access control, for your admins, applications, developers. So it's built in. Also, it has built-in integration with a lot of Azure resources. SQL Server for one, right? So you could configure a SQL Server to use Azure Key Vault and then encrypt all the encrypt the database, and it's inbuilt. Supports both server-side and client-side encryption. Server-side, what I just mentioned with SQL Server, and it could be used as an encryption as a service, where you in your application you call Azure Key Vault to encrypt your data and then store that encrypted content in a data store. It provides audit and monitoring capabilities. Suppose bring your own key. What Microsoft claims is if you bring your own key, and Microsoft within Azure Key Vault, they only do crypto operations. There's no way for anyone to view those keys. So your keys are protected, and provides a high SLA. Microsoft claims that the high SLA obviously, and also typically if you look when you use HSM, there's a performance impact. Microsoft claims because they are worldwide and they have well distributed HSM, so that reduces that performance impact. They have two types of keys. One is the RSA key, Vault key. That's basically just like the way it was in Kubernetes, where your the crypto operations using RSA key Vault is executed in software, right? And then what you do is that key itself is encrypted with a key which is in HSM. So use the HSM to protect your keying material. And then the other one is the HSM itself, where the key is in HSM, but all the crypto operations are happening within the HSM protected boundary. In terms of access control, I covered already. It's well integrated with Azure AD. They have, for managing Vault, they have a management plane API that's basically used to create the Vault service itself, and Vault access policies. Use Azure AD for authentication, role-based access for authorization. And then we have the data plane API, which is a different set of APIs that your applications will call to create keys. For crypto operations, it uses Azure AD for authentication again, and also for the data plane API, it doesn't use the role-based access, but the Vault access policies for authorization. That was created using the management API. Yeah. Can we?
Yeah. Okay. Let's talk.
Okay.
Okay. Let's talk about the AWS Secret Manager. And this is the secret management solution provided by the AWS platform. Again, like the ones we discussed earlier, again, it's a centralized secret management solution. The way it typically works is that as administrator, let's say you go and create a new set of credentials in your RDS. After that, you would go and configure that in the AWS Secret Manager. You would also specify the access policy over there saying, okay, who can access that? Like I can specify this secret is accessible by my custom app. After that, the my custom app would try to authenticate to Secret Manager. And Secret Manager, once authenticates that and verifies the access policy, it should return those credentials back to the application. And then as part of point 5, it would be able to connect to the database using those credentials. Now, in terms of feature, it provides, again, secure secret storage. What it does, it uses basically the AWS KMS to encrypt or decrypt the secrets using the keys owned by the customer. So again, they also support bring your own key. What they do is for each secret, they generate a new data encryption key, which is basically encrypted by the key encryption key stored in KMS. And after that, the encrypted data encryption key plus the encrypted secret both are stored in the secret manager. So whenever it needs to decrypt that content, it would decrypt that data encryption key using KMS, and after that, it should be able to decrypt that secret stored in the secret manager. In terms of access control, like all other services of AWS, it uses AWS IAM, Identity Access Management module, to manage the policies over there. It supports 3 types of policies. One of the very common one used is identity-based policies, which basically means that this secret is accessible by a user who either belongs to this group or who has this particular role. You can also have the resource-based policy where you can explicitly specify for this particular secret, this is accessible by this person. Or you can also have a tag-based policy, which example for that could be all the secrets tagged with team 1 should be accessible to all the users who are part of group team 1. So that could be the tag-based policy over there. Now, in terms of the rotation of the secrets, that's a very cool feature of AWS Secret Manager. What it supports that it at predefined frequency or predefined time, it would go ahead and change your credentials or secret automatically. For example, they have a built-in support for AWS RDS database. What it means that after every 30 days, it would change your database credentials over there. And the way it works is it would, at that particular time, it would create a new set of credentials in your RDS, and then it would ask application to verify that it is able to connect to that database using those credentials. If yes, then it would basically permanently change those credentials in both systems over there. For other services, you need to implement the custom Lambda function. It also provides very detailed audit and monitoring of secret usage. You can use AWS CloudTrail to view the logs, or you can also use the CloudWatch, AWS CloudWatch to receive the notifications via email or push notifications. In terms of recommendations, as I said, you can use your customer master key, probably a good idea. You should also protect your master key, because if you lose that, no way to recover your master key over there. One thing I didn't mention earlier is the application which needs to talk to the AWS Secret Manager would require some set of AWS keys over there so that it can authenticate to the AWS Secret Manager. Make sure you're not using your root account keys over there. Make a user which has limited privileges and should only be able to access that Secret Manager API over there.
So the solution that we've looked at till now is mostly a centralized solution, but because Ansible is so popular, so we thought we'll look at Ansible also. So the solution for Ansible is a little bit different. It's decentralized, allows users to encrypt secrets for Ansible projects. Right? So the way it works is you have an Ansible Vault, which you can use that to encrypt your configurations, your playbooks. Once you have and then you persist your encrypted playbooks. And when you have to execute the playbook, you provide your password to Ansible playbook, which would then execute the decrypted playbook. and it uses an AES key which is derived from the password that you provide. In terms of features, it's a decentralized secret protection, asymmetric key that's derived from a password. It can encrypt any file used by Ansible, and it provides you tool to manage the encrypted content. So you can create encrypted content, or you can, if you have your playbooks already, you can just encrypt them directly. And then finally, you provide the passwords to Ansible playbook. There are different ways of providing the password. One is prompt, that requires a manual person to enter the password. Otherwise, you'll have to, they have mechanism to get the password from a file, but you again go back to, if your password is also over there, then it's an issue. Don't forget the password. There's no recovery mechanism. I mean, your key is based on the password, so yeah, protect your password. Be aware that providing the password in an automated solution, this is again, well, that's a chicken and egg problem, right? How do you protect that initial, secret? No audit capabilities, limited access control, no authorization, but maybe not an issue because it's very, very specific to Ansible, right? So you're trying to protect your Ansible projects and trying to protect secrets, if you have secrets within those playbooks. So in terms of the conclusion, I mean, we started with a business need, so it's important to understand that it is important. It is as important to protect your configuration data as to protect your business sensitive data. Where possible, we should try to use a central secret management system. You'd be mindful of some of the security features, or rather, when we are using it, try to use it in a secure manner. Right, there are pitfalls that are there if because of misconfiguration. So use strong authentication, limit access to need bases, rotate keys and secrets, audit and monitoring. So there's no one solution that fits all. Right, it depends on your needs. And also the platform that your applications are deployed on. We just listed some of the, the highlights of all these. It's not a comparison. So, I mean, you could make a choice based on the platform that your applications are deployed on, or you may want a platform agnostic solution. It's good to look for a solution which is HSM backed if you want a really good secure solution, and you could use Gemalto's HSM on demand. And and if you want to limit, if you want to have rotation, limit the lifetime that the passwords are available, then look for a solution that had secret rotation. So the question is, salting. Using salt for the cipher algorithm. That's what your question, right? So we didn't cover that. I mean, that's too low level, and I mean, usually it's assumed with the cipher algorithms that we are using. And it's not more about the ciphers. We didn't spend a lot of time on that. It's more high level.
How do you recommend that we implement HA or disaster recovery if we're using HashiCorp Vault or Ansible Vault, because it's not automated?
So yeah, and I mentioned that even in my presentation. Yes, that's an issue. One approach you can do is probably don't host your HashiCorp Vault probably as part of your cloud solution, and probably manage that as a separate VM. So that if your cloud VM goes down, it should not affect that. One thing is HashiCorp provides a HA solution over there where you can host that in multiple machines. So even if one goes down, it should be running on the other one. So it comes with a HA availability or high availability support over there out of the box. So yeah, it's the option is there, but the problem with that, if you, for example, put that in something like OpenShift or Kubernetes, if that system goes down, then what should you do? Because over there, the containers keep on going down and up, right, every time. So that's why we were saying that, okay, you probably don't want to put that on the cloud solution over there, and maybe put that on some separate VM so that that is more controlled by you, and then you can host that on multiple machines so that you can take care of that easily. Did I answer your question? Any other question? Okay, in that case, thanks everyone. Thanks for being here.
Thank you very much.